11.3 Surface areas of pyramids and cones. The objective in this lesson is to find the surface area of pyramids and cones. So once again, we'll start out with some vocabulary. A pyramid is a polyhedron, that's our 3D figure, in which one face, which is the base, can be any polygon, and the other faces, which are lateral faces, that's around the middle, are triangles that meet at a common vertex called the vertex of the pyramid. And we name our pyramid by the shape of the base. So a lot of this is very much like our prisms, only in prisms we had two bases. In a pyramid we have one base. And then we have our lateral faces. In our prisms, they were rectangles. In our pyramid, they are triangles. And a pyramid has a point up at the top called the vertex. Now, the altitude of our pyramid is the perpendicular segment from the vertex to the plane of the base. So here is our altitude, okay, from the vertex perpendicular to the base. So it hits the middle of the base there. This is the height of the pyramid. Now, a regular pyramid, just like with prisms, a regular pyramid, the base is a regular polygon. That means it's equilateral and equiangular, and its lateral faces are congruent isosceles triangles. Now, I'm sure you can tell this makes everything much, much nicer. So we like that a lot. We have a new term here, the slant height, which is a cursive L, and keeping your slant height with the proper notation is important, is the length of the altitude of a lateral face. This is going to be right here. This is going to be the height of your face, of the lateral face, of the triangle that is the lateral face. So keep that separate from the height of the pyramid. Okay, this altitude is the height of your pyramid. So those two are very different things, and it's important to know which is which. Again, we are going to assume that pyramids are regular and right unless otherwise stated. So surface area is just like what we did for prisms. It's going to be your lateral area plus the area of one base. But let's take a look at our lateral area here. The lateral area is the sum of the areas of your lateral faces. Now we said that these lateral faces are congruent isosceles triangles. So let's take a look at this triangle. How do we find the area of a triangle? Well, the area of a triangle, you know, is 1/2 base times height. That's an H. Let's take a look at the height here. What is the height of this triangle? This height is the slant height. And what is the length of the base? Well, the length of the base is the length of one side of the base of the pyramid. So the area of this triangle is 1/2 the length of the side of the base times the slant height of the pyramid. And if you remember, when we did regular polygons, we unrolled our regular polygons and multiplied them all by the perimeter. Well, take a look at this. What happens if we put all four of these, 2, 3, 4, all four of these triangles in a row, and we do 1/2 base times height? Well, what's our height? Our height is the slant height here, right? Area of a triangle is 1/2 base times height. Our height is our slant height. And where does the base come from? Well, the base comes from that right there. That is the perimeter of the base, just like we did when we did our regular polygons, area of our regular polygons. So let's look at our formulas. Lateral area is 1/2 times the perimeter of the base times the slant height, which is the height of the face. And surface area is lateral area plus the area of the base. Don't forget, big B is area of the base. Let's take a look at an example here. We want to find the surface area of our hexagonal pyramid. We know surface area is lateral area plus the area of the base. So for lateral area, we know that lateral area is 1/2 times the perimeter times the slant height. And we can see right here that our slant height is 9 inches. And we have our base is a hexagon. So we can find the perimeter of our hexagon. We know that that is just number of sides times side length, which is just going to be 6 sides times 6 inches. Our perimeter of our hexagon is 36. So we can find lateral area, and then we need to find the area of the base. How do we do that? We know how to find the area of a regular hexagon. We know that we are going to have a 30, 60, 90 right triangle, which means that this side is 3, our apothem is 3 square root 3, because that is true for every hexagon. And the area of the base, big B, of a hexagon is 1/2 times the apothem times the perimeter. And so that is just going to be 1/2 times 3 square root 3 times our perimeter, which we know is 36. And so if we look here, we can find surface area is 1/2 perimeter times slant height plus 1/2 times the apothem times the perimeter. And we throw all that into our calculator, and we get surface area is about 255.5 inches squared. Now it's your turn. Go ahead and pause the video and do the next couple problems. All right, we were given a square pyramid. That means our base is a square. Yay! With side lengths of 5 meters and a slant height of 3 meters. So I just drew my pyramid, and we were asked to find the surface area. First, I found the lateral area, which I need perimeter and slant height. The perimeter of the base is just 5 times 4, which is 20 meters. My slant height is given. My lateral area, write my formula, plug it in, and I get 30 meters squared. Then I need the area of the base. The base is just a square. Base times height, I get 25 meters squared. Surface area is lateral area plus the area of the base, and I get 55 meters squared. Now, I want to give you a hint here. how to draw a pyramid. If you draw the base and draw it at a little bit of an angle, we have a square, but when we're looking in 3 dimensions, it's tilted. So I'm just going to draw a parallelogram. And then I know that a pyramid has a point at the top. So I imagine coming from the middle of my base and going up here. There's my pyramid point. And now I just attach my sides. And it's not the prettiest pyramid, but it definitely works. So there's a little trick at drawing pyramids. All right, the next problem says, what if your slant height is doubled? Well, how does that affect the lateral area? Of course it's going to double the lateral area because slant height is multiplied in the lateral area formula. So if we are 2 times bigger, if the slant height is 2 times more, then our lateral area is going to be 2 times more. All right, that was pretty easy. Yes, guess what? It gets harder. What if, let's go to here. What if we are not given the slant height? Whatever shall we do? Well, if we know the height of the pyramid and the length of the base, we can find the slant height. So this piece right here is 1/2 of our side length. This piece right here is the height of our pyramid, and that lets us find our slant height. And yes, how do we do it? Pythagorean theorem. So that's all this does. Use the Pythagorean theorem, get your slant height, and then you can find everything you need, lateral area and surface area. So we don't really need to go through this problem. And that means it's now your turn. Go ahead and pause the video and try the next problem. These 2 problems here are related. I'm actually going to answer part B first because it will help us with part A. It says, how does the slant height of a regular pyramid relate to the pyramid's height? And if we look here, the slant height is the hypotenuse of the right triangle, and the pyramid height is the leg of our right triangle, along with our, well, in this case, because it's a hexagon, the apothem length, or half of a side length if it's a square pyramid like we saw before. So that's going to help us here. We don't have a slant height. We want to find the lateral area, so we need a slant height. So I just drew my triangle. The height is 42 feet. The apothem is 18 square root 3 feet because our side length is 36 feet. Half of that is 18 and it's square root 3. We know that because it's a hexagon, a regular hexagon. So I just use Pythagorean theorem, put in all of my numbers, and 42 squared plus 18 square root 3 squared, that's 18 squared. And square root 3 times square root 3 is 3. So I got 324 times 3. That's where that comes from. And then, so all of that equals L squared. And I took the square root. And you will notice here that I left the slant height in terms of the square root. We'll talk about that in a second. So I know I need my perimeter for a hexagon. That's just NS. So I got 216 feet. The slant height is the square root of 2736. Write the formula for lateral area, plug it in. The square root of 2736 is an irrational number. You know that we round the very last possible thing. So I left my slant height as a square root and put that number in my formula so that when I put it all in my calculator, I get out the most accurate decimal that I can. All right, so that wasn't as bad as it looked. All right, moving on to cones. Cones, just like cylinders, are circular pyramids, but we know how circles are, so they have their own name. A cone has one base and a vertex, and this time the base is a circle. So this is just a circular pyramid, but it's okay. We'll call it a cone. In a right cone, our altitude is the perpendicular segment from the vertex to the center of the base. This is just the height of our cone. From the vertex to the center of the base, this is our altitude. This is just the height of our cone. That's the height. The slant height, still cursive L, is the distance from the vertex to a point on the edge of the base. So because we have no sides on our base, we're just going to somewhere on the edge of the base. So it's still just the slant height. Now if you notice here, our diameter is going to make a nice right triangle between our slant height and our cone height, which means that if necessary, we can use our Pythagorean theorem to find one or the other using our radius. Again, we are going to be able to assume that a cone is a right cone unless we are told otherwise, and we do want things to be right cones. Okay, so let's talk about lateral area and surface area of our cones. Let's look at our formulas here. It's very much the same as a pyramid. Let's draw our net. What does this look like when we unroll it? Well, it's almost a triangle, isn't it? Not quite, and then we'd have a circle here. Almost a triangle, but not quite. We can still kind of think of it as a triangle, and I say that loosely. There's our slant height. But what is this? This is just the circumference. So we do 1/2 base times height. What's the base? The circumference. What is circumference? 2 pi r times the slant height. If we do 1/2 times 2 pi rl, our 1/2 and our 2 cancel, so lateral area is pi rl. And surface area is just lateral area plus the area of the base. What's the shape of the base? The area of a circle is always pi r squared. So surface area is going to be pi r l plus pi r squared. These two formulas are for every cone. Just like with cylinders, this is why circles are special. They have one formula and one formula only. So lateral area and surface area, these are the only formulas you need. Let's take a look at a problem here. What is the surface area of the cone in terms of pi? Well, what do we know? There's our slant height. There's our radius. That's all we need. Surface area is pi RL plus pi r squared. We substitute in, and surface area equals 600 pi centimeters squared. So that's all there is to cones, and we could multiply by pi on our calculator and get an answer in decimal form if we wanted to. That means that it's your turn. Go ahead and pause the video and do the next problem. This was an easy problem. I just drew my cone. The radius of the base is 16 meters. The slant height is 28 meters. Surface area, wrote my formula, substituted in. We wanted it in terms of pi. So I got 704 pi meters squared, and I can also put that in my calculator, multiply by pi, and I got 2,210.6 if we wanted a decimal. So once again, our circular solids are much easier, and that is why they are special. Moving on. This picture right here shows us what we just talked about. Area of a triangle is 1/2 base times height. The base is the circumference. The height is your slant height. We already discussed that. Okay, what if we only want the lateral area? Well, then we just use the formula for lateral area, pi RL. In this case, what are we given? We are given a diameter, and we are given the height of the cone. Oh no, whatever shall we do? We just simply draw a right triangle, and we label what we know. This is going to be 40 millimeters. This is 45 millimeters. And here is our slant height. So we just do a squared plus b squared equals c squared. Don't forget your hypotenuse is always c. So 40 squared plus 45 squared equals our slant height squared. And once again, leave that in as a square root and put it into your equation. Notice here they didn't even bother to add them together. The calculator can do all that. I would add them together and then use it as a single square root. You put it in your calculator and find the answer. And that means now it is time for you to do the last two problems. Go ahead and pause the video and give them a try. The first problem was very straightforward, is exactly what we just did. We had a traffic cone with a radius of 10 inches and a height, a cone height of 28 inches, and we wanted to find the lateral area. So we had to use the Pythagorean theorem to find the slant height, because we needed the slant height to find lateral area. I found my slant height was the square root of 884. Plugged that into my formula with the radius and got a lateral area of 934.1 inches. Now the next problem says that the radius of the cone is cut in half, but your slant height remains the same. How does that affect your lateral area? Well, of course, it's just going to cut it in half, because if we take radius divided by 2, we're just dividing our equation by 2. Now, something to think about, we weren't asked, but something to think about here, if our cone height had stayed the same and our radius had changed, it would be less than half, because notice here in our Pythagorean theorem that the radius will affect the slant height, because we'd be doing 5 squared instead of 10 squared. So it would actually be less than half if our cone height stayed the same. We weren't asked that, but it's an interesting thought to have anyway. So once again, with surface areas of pyramids and cones, it's all about labeling, making sure that you have the right parts where they're supposed to be. Keep your pyramid height separate from your slant height. Use the Pythagorean theorem if necessary. And cones are super easy because there is just 2 formulas that you need to know. So work carefully, and I'm sure you will do great on these problems. Enjoy your homework, and don't forget to do your video quiz.